Hi, welcome to section 11.2 notes. This is on surface area of prisms and cylinders. So section 11.2 and 11.3 are both going to be on surface area, and then in 11.4 and 11.5 we'll move into volume of those same figures. So first of all, a prism is a polyhedron with two congruent parallel faces called bases. And prisms are named by the shape of its base. Okay, so if we look at these two examples down below here, again, any polygon can be the base. Okay, so it can be a hexagon, a pentagon, a triangle, a square, a rectangle. The bases can be any polygon, anything made up with the straight edges. And then the lateral faces that kind of connect the two bases are generally going to be like a rectangle or a square. Okay, and those lateral faces kind of go around the figure from there. But again, a prism is always going to have two congruent parallel bases. Okay, so two bases that don't touch each other, but they're the same shape and the same size. The lateral faces, like it says here, are the other faces that are not the bases. Okay, so you can kind of see the different parts of these. The first one on the left is a pentagonal prism because the two bases are pentagons with 5 sides. And then the next one is a triangular prism because the two bases are triangles. Keep in mind, though, that sometimes the prisms are laying on their side. Sometimes they're kind of vertical, like we see that here. And sometimes people mess up what the base is because they think the base is always what the bottom of the figure is or something. And so then when it's like if this triangular prism was on its side, people might say the base is a rectangle, but that wouldn't be true because the rectangles, there's not two parallel rectangles that don't touch each other. All the rectangles, touch another rectangle. So again, make sure it doesn't matter how the figure is kind of flipped or turned. You want to be looking for the bases as being the two shapes that are the same shape, same size, but they don't touch each other. They're kind of across from each other. All right, the lateral area, which we can abbreviate as LA, is the sum of the areas of the lateral faces. And remember, sum just means you're going to add up those areas. The surface area, or the total surface area, is the sum of the lateral areas and the area of the two bases. Okay, so again, lateral area is just part of the surface area. When we're talking about surface area, we're just talking about the area of each outside surface. We're not talking about how much the whole figure takes up. That would be the volume, like how much water or sand I could pour in the figure would be volume. How much, wrapping paper I needed to wrap the whole outside of it. That's what we're talking about with surface area. So again, lateral area is everything except for the bases, and the surface area is referring to the total surface area, which also includes the area of the bases. All right, in terms of finding the lateral area and surface area of a prism, you can see the formulas here. It says the lateral area of a right prism is the product, which again means you're going to multiply, product of the perimeter of the base and the height of the prism. So, if you look at these figures, hopefully you understand that you could just find the area of all the different polygons that make up that figure and then add all those up. That would give you the surface area. You could find the lateral area separate from that. But these formulas help do it in kind of a quicker method. It's kind of taking all of those areas into account and putting it into one formula. So you can see when it says lateral area, that technically if you take the perimeter of the base, so one of the bases, find the perimeter, which is again the distance around that base, and then multiply that by the height, which is always the right angle distance in between the two parallel bases. That would give you the lateral area, which again is everything except for the bases. The surface area of a right prism is the sum of the lateral area and the lateral area of the two bases. So again, that means that capital B stands for area of the base. Sometimes people think the B just means base and they just put one number in for the base, where usually I find the area of the base off to the side, but the area of the base means you actually have to use another formula to find the area of the base. And keep in mind that, that formula can change depending on what shape the base is, whether it's a hexagon or a rectangle or a triangle and so forth. What formula you use to find capital B is going to change. So that's what gets us into the chapter 10 formulas that we just worked with. Okay, so again, make sure you're doing something to find out what the capital B is, and then you can plug that into the surface area formula and finish from there. So here's a couple examples about finding the surface area of a prism. It says round the answer to the nearest whole number at the end. Always pay attention to the directions in terms of rounding. Sometimes they might say to the nearest tenth, sometimes the nearest whole number. So just pay attention to that. So these two examples are kind of stepping you through how to do those. So if we look at this first picture, we can see that this is a prism. You can just call it a general prism or rectangular prism. And technically on a rectangular prism, it doesn't matter what you pick the two bases to be. You could either pick, in this particular picture, you could pick the top and the bottom, the right and left side, or the front and the back side, because all of those scenarios have two parallel congruent bases. They're both rectangles. They're both congruent. So it doesn't technically matter which one you pick, but once you pick one, you've got to stick with that one for the rest of the problem. So I'm just going to pick the top and the bottom of the figure. So that's a base and that's a base. If you pick the right and left side of the front and back, you're still going to get the same answer in the end, but our work is going to look a little different leading up to that. We'd get a different lateral area, which is okay, but then by the time we got the total surface area, we'd have the same answer. So if we look at this lateral area, we again said is P times H, perimeter of the base, times the height, or the right angle distance between the two bases. And so for the perimeter of the base, you can see we've got 4 plus 3 plus 4 plus 3. Okay, we're adding up the four sides of that base, and if we add those up, we get 14. And then the height, again, is the right angle distance between the two bases. And in this case, that's going to be 5. And now if I multiply 14 times 5, I get 70 centimeters square. Again, we're finding area, so make sure you have your squared units. For the total surface area, there's different ways you'll see the formula. Sometimes they go ahead and have pH in for the LA spot. Either way is fine. I think I have 2 formula sheets attached to the notes packet, and either one is fine. Some people prefer to find the lateral area off to the side and then plug just the 70 into the surface area formula. So that's what I have here. So we can see the total surface area is the lateral area that we already found, plus 2 times the capital B, which stands for the area of the base. So don't forget about the 2, because there's 2 bases. And then the area of one of the bases, if we look at our bases that we identified, we have a rectangle, and we know that to find the area of a rectangle, we just need to go base times height. And so in this particular case, it's 4 times 3, which is 12. So some people prefer to do that off to the side and then just plug that 12 into the formula. In this particular case, you can see they have a spot for you to actually show that you're multiplying those. And then 4 times 3 we know is 12. And now if we work it out from there, we know we're going 70 plus 24, and that gives us 94 centimeters squared. Again, sometimes just be careful to the little details. Sometimes people will, put this 12 here, but they'll forget to double it. Little things like that. So you'll have a formula sheet. You don't have to have the formulas memorized, but you do need to remember what these letters stand for in the formula. And then just be careful to the details when you're working it out. But look at number 2. This one is also a prism, but it is a triangular prism because the two bases are triangles. Those are the congruent parallel bases. Again, even if this figure was kind of laying down where a rectangle was at the bottom, it would still be a triangular prism, not a rectangular prism. All right, if we go and work out this one, the lateral area is P times H, perimeter of the base times the height. The perimeter of the base, if we look at this one, sometimes they give us numbers at the top triangle, sometimes at the bottom. Sometimes you have to kind of combine those together. But in this case, we have a 3, we have a 4, and we don't know what this length is here. So we have to find it. So sometimes what I tell people is if you just draw just the base, sometimes it helps you focus on that. For a moment instead of having to focus on the whole thing. And sometimes that helps you be more careful with picking the right numbers to put in the formula. So in this particular case, if I look just at that right triangle and I want to know the third side of the triangle, I realize, oh yeah, I can use Pythagorean theorem, a squared plus b squared equals c squared, and I can find that third side since it's a right triangle. So you can see the work here for that, and you can see that that x ends up being 5. Okay, so now for perimeter of the base, I can say 3 plus 4 plus 5, which is 12. And 6 is the distance between the two bases. So that's my right angle distance between the two bases, and that is 6. So when I'm looking at the height, I'm talking about the height of the whole prism. So now I'm not just looking at the base anymore. I'm looking at the distance between the two bases. And then now if I multiply 12 times 6, I get 72 centimeters squared. All right, for surface area, again, it's the lateral area plus 2 capital B. The lateral area we already found, so we can see plug that 72 in, plus 2, don't forget the 2. And now the area of the triangle base. So in this case, again, if you want to do this off to the side, you can. The area of the base, if I think of it that, I can look up here, it's a triangle, and so I know the formula for the area of a triangle is 1/2 base times height. Again, remember that 1/2 apothem times perimeter. Sometimes people are using that at the wrong time on the chapter 10 test. That is only used if it is a regular polygon, which means all the sides and all the angles are congruent, which means it would be an equilateral and equiangular triangle. This is not the case for this triangle, so we can't use that formula. So in this particular case, I'm looking just at this right triangle base. So that's where I'm saying 1/2 times 3 times 4, because I know that they have to form a right angle with each other. And then if I multiply that out, then I get my 6. Okay, so that's the area of one of the bases. But again, this 2 in the formula doubles that 6 to end up giving us the area of the whole base. So some people like to find that area of the base off to the side. That's generally what I do. The way the notes have it here is they're plugging that information into the formula, and that's fine too. You'll get the same answer. So in this case, the 1/2 base times height is the 1/2 3 times 4. If you multiply all of that, then you get 12 because you're already doubling it by this 2 here. The 1/2 3 times 4 gives you 6, and then that times 2 gives you 12. And now 72 plus 12 gives you the 84 centimeters squared. All right, moving right along. So try and think of what type figure this one is, and hopefully you are thinking a pentagonal prism because the bases are pentagons. So same idea, this one's just a little bit more work because of the base being a pentagon. So if I go and write down my lateral area formula, which is pH, sometimes they'll just ask you for the lateral area, sometimes they will just ask you for the total surface area, and sometimes they'll ask you for both. So just make sure that you're prepared to do one or the other or both if needed. So in this case, we're going to assume these pentagons are regular polygons, which means all of the side lengths of this base are 5. So when I want to find the perimeter of the base, I know that it's just like we used before, n times s, there are 5 sides, and 5 is the length of each side, so it's 25 for the perimeter. The height is the distance between the two bases, which is my 11. And when I multiply that out, I get 275 centimeters squared. Okay, now for the total surface area, let's switch colors for that. I've got pH plus 2 shall just write lateral area. You know, sometimes people here will write pH plus 2 capital B. Sometimes they write just the lateral area plus 2 capital B. So either way is fine. And from there, you know, the lateral area I just found is 275 plus 2 times capital B. So capital B, I'm going to do off to the side here. Fix that. That doesn't look very good. So capital B means I need to find the area of the base. The base is a pentagon. It's a regular pentagon. So that's where I can do the 1/2 times the apothem times the perimeter. So here's where I think it's important to draw the actual base over here so that I can just focus on it and I can draw on it without having to get confused with the rest of the picture. So I went ahead and did that. It's not the best looking regular pentagon, but it'll work. From there, remember, just like we did in section 10.3 and 10.5, I can make this right triangle. And I need to do my 360 divided by my 5 sides, which gives me 72. And then remember, if I draw the apothem through the middle of that 72, I end up with 72 divided by 2, which is 36. So I know that if I draw an apothem down through the middle of that forms a right angle at the base, then I know that this angle, it's not showing up good, is 36. I also know that this angle down here is 54. Okay. And that's referring to this angle right here. All right. So from there, I know that the length of each side here, you know, is 5, which therefore I know that this piece from here to here is 2.5, but I don't know what the apothem is. So I need to do a little work to find the apothem. I can use the 36 or the 54 to do that. I chose to use the 54. I have to decide if I'm using sine, cosine, or tangent. And in this case, I end up using tangent because across from the 54 is the apothem. The adjacent leg to the 54 is the 2.5. So I can say tangent of 54 is equal to opposite, which is the apothem, over the adjacent, which is 2.5. If I put a 1 underneath here, I can cross multiply. 1 times A is A, and 2.5 tangent 54 gives me my apothem. So over here, for area of the base, I've got 1/2 times the apothem, 2.5 tangent 54, times the perimeter of the base, which I already did. I already used that over here and found that it was 25. So that's not changing. I don't need to do that work again. And now if I go ahead and get that simplified down a bit, then if I go, let's see, if I do 0.5 times 2.5 times 25, I get 31.25 tangent 54. Okay, yes, it's a decimal, but I didn't round anything. That's exactly, you know, when my calculator says 31.25, that's not a decimal that keeps going. So that's still exact. So if I take that number and come plug it over here into my capital B and my surface surface area formula, then I'm running out of room here, but I'll fit it in there. So that's everything I need. So now if I go ahead and do 2 times that, since there's 2 bases, 2 times 31.25 is 62.5, tangent 54. And then now if I go and plug it in my calculator from there, then I get my total surface area is 361.0 centimeters squared. So if you just wrote 361, that's fine. All right, so that one is a little more to it. It brought in that chapter 10, that chapter 8 stuff because we had to find the area of a hexagon. But besides that, it was like the other two that we did. Okay, next up is a cylinder. So a cylinder is like a can, a Coke can or a green bean can or whatever, oatmeal container. But for that, the lateral area of a right cylinder is the product of the circumference of the base and the height of the cylinder. Okay, so the lateral area is kind of just the curvy part that goes around the figure. And again, the circumference is basically the perimeter of the circle plus the height. You're basically just kind of accounting for the circumference is the distance around one circle, and then you're multiplying it by how much the height is to account for all the circles kind of stacked on top of each other. The total surface area of a right cylinder is the sum of the lateral area and the sum of the two bases. So again, you don't want to forget there's two bases, there's two circles as the bases, and that's what gets accounted for here. Now, since the base of a cylinder is always going to be a circle, and for the lateral area, it's always going to be a circle, the base. That's why they have kind of a more specific formula here for a cylinder, which actually makes it a little bit easier to use because we basically have the circumference 2 pi r times the height, the distance between the two bases, is what gives us the lateral area. And then 2 capital B, the capital B is the area of the base, and we know the base is always a circle, and the area of a circle is pi r squared. So that's what got plugged in here, the pi r squared, and then you're doubling it to account for both bases. Okay, so that's a little more helpful when the formula is written that way. But if you start with the generic formula here, you'd still get the same thing. Okay, this just shows you a little picture of where this is coming from. To visualize it a little more, if you kind of had an oatmeal container or something and you cut along the circle bases and cut along kind of one side of the container and open it up flat, then that's what these would look like here. You basically would have a rectangle of cardboard and two circles. So if they're making a oatmeal container, they may be starting with these shapes that are out flat in cardboard, and then they're kind of bending them and putting them together to make that oatmeal container. So you can see here the circumference of the base is 2 pi r, and that's getting multiplied by height since it's a rectangle, and that's where that comes from right here. And then the total surface area is just adding in the area of the bases. And again, if you know the radius of a circle, then you can therefore find the area of that circle. All right, so just 2 cylinder ones here. Again, they're generally a little easier for people, not as much variation. So in this particular case, we want the lateral area, which we just said is 2 pi r h. Well, we can see the radius goes from the center of the circle out to the edge of the circle. And we can also see the height of the cylinder is the distance between the two bases. So in this particular case, just be careful, I guess, with this. Sometimes they'll give you the radius and sometimes the diameter. So pay attention to that little detail. 2 times pi, they gave me the radius this time, which is 3. The height is the distance between the two bases. And if I go and multiply those out, I get 30 pi centimeters squared. Just pay attention to the directions on these. This one says leave the answer in terms of pi, so I'm not multiplying by pi. The surface area here is the lateral area plus 2 capital B. If you want to start with the generic formula, we know the lateral area is 30 pi. We know that the capital B is pi r squared. So if I get more specific here, I know the radius is 3, and don't forget to square that. For the cylinder formula, I generally plug the information right into the formula, whereas some of the prism ones and things like that, I'll kind of do the work off to the side and then plug the number in, but that's just a matter of preference. So here I have my 30 pi again, and then plus 3 squared is 9, 9 times 2 is 18 pi. If I go and add those up, I get 48 pi centimeters squared. So if they asked for it in exact form, or they said leave answer in terms of pi, this is what I would do. I would not multiply by the pi throughout the problem. If it does want me to round to the nearest tenth or the nearest whole number, I would use my pi button on my calculator when I multiply, not 3.14, and that would keep it more accurate. Okay, so in the next case, I will show you this one, and again, it's very similar. The biggest thing here is that they gave me the diameter, not the radius. So the diameter is 10. I know the radius I need to plug in is 5. And the height here is 12, the distance between the two circle bases. So if I go and multiply those out, I get 120 pi centimeters squared. And then for the total surface area, again, I want to show you how the other way that you sometimes see it written. Sometimes you just see the surface area as 2 pi RH plus 2 pi r squared, instead of the LA and the capital B and all of that. So I've already found the 2 pi RH. That's my lateral area that I just found, 120 pi. I don't need to rethink that again. But this part I haven't done yet. So I've got 2 times pi times the radius, which is 5, and I need to square that. So I've got 120 pi plus 25 times 2, which is 50 pi. And if I go and add those up, I've got 170 pi meters squared. All right, so that is it for the surface area of a prism and a cylinder. The next two we will end up doing are a cone and a pyramid. And then we'll end up doing the volume of all four. So that's it for 11.2. Let me know if you have any questions.